Okay, so the next function that we're going to be graphing is this one right here, y equals negative the cubed root of x plus 3 minus 4. I just wanted to analyze this function and talk about our movement and what's going to be happening before we go ahead and graph it, okay? So the first thing that let's look at is this negative here. Like we talked about with the square root function, the negative means that we are reflecting over the x-axis. Okay? We're reflecting it over the x-axis. This part right here, if we set x plus 3 equal to 0, we have that x equals negative 3. So that will be our x-coordinate for our new point of inflection, negative 3. We always want to start graphing something by graphing our new point of inflection. And this right here tells us that we are moving down 4. So our y-coordinate for our point of inflection will be negative 4. Just so you guys know, I'm looking at number 8 on your day 5, unit 5 notes. I'm looking at that graph right there. So far we've seen that we're going to be reflecting this guy over the x-axis. We're moving the point of inflection to the left 3 and down 4. And this will be our new point of inflection. Okay, so what happens when we reflect something over the x-axis? Let's think about that. Well, my x-coordinate stays the same, but whatever's on the top of the graph will be shifted down to the bottom. So just so you guys know, just for an insight, when we had the square root function, which looked like this, the x-coordinates, which were, these guys here, they stayed the same. I didn't change my x values, but my y values moved from here, and they were negated, okay? Everything that was a positive y value became a negative y value, okay? And then the graph ended up looking like that after we reflected it. We're going to use that same logic here, okay? So I'm just going to write a little note for you guys so that you can remember this, because these cubed root graphs can get a little confusing and pretty detailed, so I don't want you guys to get lost with your points and what's going on. So just so you know, I'm going to write it in red. When you're reflecting over the x-axis, your x values stay the same. Your y values, so that's an ugly A, your y values are negated. So for example, if I had the point negative 2, 4, when I reflect it over the x-axis, that then becomes negative 2, negative 4. Okay? And one more example. If I had the point, let's say I had the point 5, 3, or 5, negative 3, when I'm reflecting that over the x-axis, negating negative 3 gives me a positive 3, so I'm left with 5, 3. So my points change in that this guy stays the same. As you can see, 5 stayed 5, and negative 3 was negated to become positive 3. Because if I multiply negative 3 by a negative, by negative 1, it then becomes positive 3. So let's go ahead and try to graph that function. So our function is, let me just write it out for you guys. It is y equals negative the cubed root of x plus 3 minus 4. Okay, this is our parent graph in black. We said that we were going to shift it to the left 3 and down 4. We were going to shift our point of inflection. So let's do that. 1, 2, 3 to the left. I'm going to move, 1, 2, 3 to the left, and I'm going to move down 1, 2, 3, 4. So that is my new point of inflection. 1, 2, 3, oops, sorry, it's a little high. 1, 2, 3, 4. That's my new point of inflection. Alright, now, normally our parent graph has that when we're to the right 1, we're up 1. That's all changed. So when we move to the right 1, in the parent graph, we're at our y equals positive 1. Now when we move to the right 1, our y flips. It's negated. So it's negative 1. So I'm moving to the right 1, and now I'm down 1. I'm moving to the right from my point of inflection. Now I'm going to move to the right 8 because it's my next perfect cube. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to be down 2 for my point of inflection. So I'm right about there. Alright? So I am moving down 2 because in my parent graph I was up 2 when I was to the right 8. When I was to the right 8 from my point of inflection, which was 0, 0. But now this is my point of inflection. I moved to the right 2, but I'm going down 2 because I've negated my y value, okay? So now let's do the same thing on the left. Here's our point of inflection. Man, my pen does not want to write. Okay. There's my point of inflection. I am moving to the right 1. And so instead of moving, I'm moving to the left 1. Instead of moving down 1, I'm going to be moving up 1 because I've negated that value. And then I'm going to move to the right 8. Let's see. For my point of inflection, 1, 2, 3, 4, 5, let's say 6, 7, and we'll call that 8 all the way at the end. Sometimes I'm moving up 2 for my point of inflection. Once I'm all the way at 8, I'm up 2. So 1, 2. So 8 will correspond to that value over there. Moving 8 to the left, not 8. That's actually not 8. It's more like, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's more like 11, negative 11 on the actual axis. But it's just shifted to the left 8 because I'm shifting left and right those perfect cubes. So now let me go ahead and connect my dots. And that's my new graph. And that is my new reflected and shifted graph, where this right here is my point of inflection, that guy right there. And we said the point of inflection was at negative 3, comma, negative 4. Okay? Let me know if you guys have questions about this. I know it's a little bit confusing. I think Mrs. Reiser and I talked about, for the sake of time and making sure that you guys really understand this, number 9 and 10 we're not going to worry about. And I think the same goes for number 4 and 5 in your packet. Those have something called stretches and compressions, and we're not going to worry about that because, I mean, you guys had snow days and all kinds of things, so I think we're just going to skip over that right now. But you'll hear more about that from Mrs. Reiser probably, like what she plans on doing with that.